So we've got a triangle picture here with lots of lengths and angles. It's not a right angle triangle, so it's more than likely to be the sine rule, cosine rule, which are given to you at the front of your exam paper. It wants you to work out the length of BC, and we've got to try and find other lengths. Question's worth 5 marks, so it's not just going to be a straightforward one calculation question. So we kind of look at the pictures, and if you remember, what we're trying to do is we're trying to decide, can we see a side angle side triangle, so the SAS type triangles? If we can, then we could use the cosine rule. If we see a side 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 triangle, so in other words we know all 3 sides, then again we can use the cosine rule to find angles. And if we see an angle side angle triangle, or we see an angle angle side, so either of those, then we know it's going to be the sine rule. So we're kind of looking at the picture and deciding what the information is that will allow us to find the missing bit, and because we can see that BC involves a side and an angle, because we do know this angle is going to be 100 degrees because angles on a straight line add up to 180. It would be a side angle. If we knew that side, then we'd definitely be able to find that length there. So it looks like we're going to have to find this side first to get the SAS triangle, which would then allow us to use the cosine rule to find out the missing length. So when we look at the triangle ABD, we can see that it's an angle-angle side triangle, and angle-angle side triangles allow us to use the sine rule to find missing sides. So it looks like we can find the length of ABD by using the sine rule. So we've got angle opposite side, so the sine rule would work. So from the front of the exam paper, the sine rule tells us that if we know the length of little a divided by the sine of big A, then it equals the length of little b divided by the sine of big B, and so forth, where we'd have a standard triangle going A, B, C, where that would be little a, that would be little b, and that would be little c. Quite often then we just look at the triangles that they give you in the exam questions, and we kind of just label up how we want it, because these letters are interchangeable. This is capital D, so I can call this little d. This is capital A, and I can call that little a. And then we can write the sine rule using those letters instead. And basically we've got to ask ourselves, do we want a length or an angle? This time we want a length, so we leave the lengths on top of the fractions. If we wanted an angle instead, then we would just switch those over to put the angle on top to make it an easier formula to use. So what we can see then is that little a over the sine of big A is going to equal little d over the sine of big D. So basically the length of A, the length of D, the angle A and the angle of B. When we look at the information, we know that little a is what we're trying to find, so it's still going to be called A. We know the big A is the angle at the point A, so that's going to be 45 degrees. And we know that the little d is 7.4 centimetres, and the angle at D is 80 degrees. So we put those into the rule, and we find that little a is going to be equal to the sine of big A times D over the sine of B. All we've done is we've recognised that this says divide by the sine of A, so on the other side of the equals the sign will change to times, so we're doing times in here. So we replace the letters with the numbers we know, so little a is going to be the sine of 45 degrees times 7.4 over the sine of 80 degrees. So 7.4 divided by the sine of 80 equals, and then times that by the sine of 45 degrees equals. So we found out the length of little a is 5.1331. Write out a bit of the number because it's not the final answer. We need to round later. So that's going to be the length of BD. So we now know on the picture then that we can label this length as 5.31331 centimetres. Now we go back to the question. The question wanted the length of BC. We can now see that we have a side angle side triangle. So we now have a SAS triangle, which means we can use the cosine rule to finally find out the final answer. So we take the picture and we sketch out that triangle to kind of identify the bits we're going to use. So we're going to use 100 degrees. We're going to use the fact that that side is 5.31331. This side is 5.8, and we then label up accordingly. So we've got B there, C there. Now the cosine rule says that you take the length of little a squared equals b squared plus c squared minus 2bc cos of the angle at A. So that would be the triangle labelled ABC, where the angle would be at A, this would be little a, this would be little c, and this would be little b. So all we're going to do is we're going to re-look at this rule and use the lengths and angles that we've been given within the question. So this gets labelled little d, this gets labelled little c, this gets labelled little b. And we can see that the length we want has been labelled little d, so that's going to replace the a squared, and the angle is going to be at capital D, so that's going to replace that. So in other words, we just rewrite the rule as d squared equals b squared plus c squared minus 2bc cos of big A. We just replace the numbers into there. We know that little d was the thing we're trying to find. We know that little b was 5.8. We know that C was what we found in the other triangle, so 5.31331, and we're taking away 2 times 5.8 times 5.31331 times the cosine of 100 degrees. So what we need to remember is that's going to be the value of d squared, so 5.8 squared plus 5.31331 squared, take away 2 times 5.8 times 5.31331 times the cosine of 100 equals. So that's going to be 72.57 and so forth centimeters squared, square centimeters. We want d, so that's going to be the square root of that. So we square root both sides. So square root equals. So 8 point, and because the question wants to 3 centimetre figures, 8.52 centimetres. So the answer here then is going to be 8.52 centimetres. So that's going to be our final answer for the question. So if we go back quickly and just remind ourselves then, we saw a triangle with lengths and angles in it. So it's not a right angle triangle, so it's a case of looking through our sine and cosine rule to see which one we can use to help us find the missing bits. And we remembered that if we've got a side angle side triangle, we can use the cosine rule. Side 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 triangle, we can use the cosine rule to find missing angles. And if we've got the other type of triangles, ASA triangle, an angle side angle triangle, or an angle angle side triangle, then we can use the sine rule to find missing values. Can't get the answer we wanted straight away. It's 5-mark questions, so that gives you a hint. You might have to do a couple of calculations. So we recognise that if we had this length here, then we had a side angle side triangle, which allowed us to then use the cosine rule to find our missing length. We can get this length though because in the other triangle we recognised it was an angle angle side triangle, which allowed us to do angles and opposite lengths. So using the sine rule we found that length. Cosine rule then allowed us to find the other value, and then we applied all of that through our workings out, and we found the final answer was 8.52 centimetres.